In the silent darkness between the stars, something has stirred. For nearly 50 years, Voyager 1 and Voyager 2 have sailed through this uncharted ocean. Recently, they sent back a message, not words, but data. These numbers reveal an unexpected disturbance, a ripple in the fabric of space itself, a whisper from the void that could challenge our understanding of the cosmos. The Voyagers have journeyed beyond the sun's protective bubble into the interstellar medium, a sea of gas and dust between stars. Here, they've detected a subtle, persistent push, a force with no clear source. Scientists at NASA noticed the anomaly after months of careful analysis. The signal was clear, consistent, and observed by both Voyager 1 and 2. The universe, it seems, is telling us something new. Decades after launch, the Voyagers remind us, the cosmos is stranger and more wonderful than we ever imagined. To grasp the significance of this finding, we must appreciate the messengers. Voyager 1 and 2, launched in 1977, were designed for a grand tour of the outer planets. Using a rare planetary alignment, they slingshotted from Jupiter to Neptune, rewriting our textbooks with each encounter. After their planetary tour, they embarked on a new mission to become the first human-made objects to enter interstellar space. Each Voyager carries a golden record, a message in a bottle filled with sounds and images from Earth cast into the cosmic ocean. Nearly 50 years later, the Voyagers continue their lonely journey. Voyager 1 is over 24 billion kilometers from Earth. Voyager 2, more than 20 billion. Their signals take over 22 hours to reach us, and their power is fading. Yet, their instruments still collect precious data from a region of space we've never sampled before. They are our silent sentinels in the dark, now telling perhaps their most important story. More than machines, they are an extension of humanity's senses. Their endurance is a testament to our curiosity and ingenuity. And now, they may be on the brink of a discovery that will define their legacy. The discovery is subtle, but its implications are immense. The Voyager probes have detected a minute, persistent lateral acceleration, a gentle sideways nudge, not a push from behind or a slowing from the front. The force is incredibly faint, equivalent to the gravitational pull of a single bacterium on the spacecraft. Detected by the Attitude and Articulation Control Subsystem, or AACS, this force required more frequent thruster firings than predicted. Both Voyager 1 and 2, traveling in different directions and separated by vast distances, experience nearly identical accelerations. This rules out a local phenomenon or malfunction. The disturbance appears to be a large-scale feature of the interstellar medium, a cosmic current in the space between stars. Scientists reviewed all possible sources of error: gas leaks, thruster degradation, software glitches, gravitational influences. Every conventional explanation was tested and found wanting. The conclusion became unavoidable. The acceleration is real, and its origin is unknown. The Voyagers have stumbled upon a new force of nature, or a previously unknown property of interstellar space. The quiet void is not so quiet after all. A profound mystery has emerged at the edge of our solar system. Let's dive into the numbers. The anomalous acceleration is about 5 times 10 to the minus 13 meters per second squared. Close in magnitude, but different in direction, to the old Pioneer anomaly. Unlike Pioneer, Voyager's acceleration is lateral, and thermal effects can't explain it. The evidence comes from AACS thruster logs, corroborated by the low-energy charged particle instrument, which shows a consistent asymmetry in plasma flow. It's as if the probes are moving through a medium with a slow, uniform sideways current. The magnetometer detects faint, organized magnetic field structures, sheet-like formations in the local interstellar region. The direction of the force aligns with these magnetic sheets, hinting at a possible link. The effect became noticeable only after both spacecraft crossed the heliopause, confirming it's a feature of interstellar space. The force is steady, not fluctuating, a key clue that this is a fundamental property of this region, not a transient event. The Voyagers are revealing a new, stable feature of the galactic environment. Science begins by eliminating the obvious. Could a tiny leak in the spacecraft be pushing them sideways? No, sensors show no leaks, and the force is constant. Gravity from an unseen object? Unlikely. Such a force would affect the probes differently, and no massive object has been detected. Could the interstellar medium itself be denser than expected, creating drag? The plasma is too sparse. Drag is millions of times too weak. Galactic forces, like the Milky Way's gravity or dark matter halo, these act on everything, including Earth, and wouldn't show up as a local anomaly. Every conventional explanation has been methodically ruled out. The anomaly is a local effect, a deviation from the expected baseline. After exhausting all known possibilities, scientists are left with a thrilling prospect. We may have found something entirely new. The universe is offering us a puzzle that defies our current understanding, and that's where discovery begins. When conventional physics fails, we must look beyond. One leading hypothesis, a modified theory of gravity. Perhaps gravity behaves differently on interstellar scales, as some theories like MOND suggest. The anomaly could be the first direct evidence of such a deviation. Another possibility, dark matter. Maybe the Voyagers are passing through a region with a higher density of a specific type of dark matter, producing a faint interaction. This would be a monumental discovery, our first non-gravitational sign of dark matter. Some theories even suggest extra dimensions. If gravity leaks into these dimensions over long distances, it could create subtle effects like the one observed. Or perhaps the quantum vacuum itself is different in interstellar space, organized by large-scale magnetic fields, creating a net pressure. Each idea is speculative, but grounded in real physics. The Voyagers may be revealing a link between the largest cosmic structures and the smallest quantum phenomena. The data forces us to consider possibilities once thought too wild. The edge of the known is where science advances. Discoveries like this are the lifeblood of science. The Voyager anomaly could mark the beginning of a new chapter in physics, perhaps a new force, or a deviation from general relativity. The significance lies in the location. The Voyagers are our first interstellar laboratories, testing the laws of physics in a pristine environment. An anomaly here suggests the universe may operate under different rules on a galactic scale. This will inspire new missions, dedicated interstellar probes, more sensitive instruments, and new experiments on Earth. The anomaly provides a clear target for particle physicists and cosmologists. The Voyager mission, designed for planetary exploration, has stumbled upon a profound mystery. It's a powerful argument for pure exploration. We find the unexpected only by venturing into the unknown. The greatest discoveries are often the ones we never set out to make. The universe rewards curiosity. To understand the excitement, let's hear from the scientists. Dr. Alara Vance, Voyager Interstellar Mission Lead. We tried to make this anomaly go away. The fact that we can't is what makes it so thrilling. Dr. Kenji Tanaka, Caltech. This is the kind of anomaly theorists live for. A clean signal, observed by 2 spacecraft in a region we've never studied. Suzanne Dodd, Voyager Project Manager. These spacecraft were built to last 5 years. Nearly 50 years later, they're rewriting physics textbooks. Dr. Eris Thorne, Philosopher of Science. The Voyager anomaly shows how science progresses, not as a straight path, but as a journey through the unknown. The anomaly is sparking debate, new theories, and a renewed sense of wonder. The journey is far from over. The next chapter is ours to write. We stand at a remarkable moment in our cosmic journey. 2 probes, built with 1970s technology, have sent back a riddle from the space between the stars. A persistent, unexplained sideways force, surviving every attempt at explanation, beckons us to look deeper. The data is clear, the implications profound. We followed the evidence, ruled out the obvious, and now confront the unknown. The legacy of Voyager is now twofold: a grand tour of the outer planets and the first encounter with a truly galactic mystery. This discovery is a reward for our audacity to explore. The journey of Voyager continues, and so does our own. The probes will sail on, carrying our curiosity into the darkness, and we are left with a question that will drive science for decades. What else is out there, waiting to be found?